Hi guys, welcome to another episode of Spec Talk. Quite different from last two as you can search it out on Spec List. This time, we will reveal some undisclosed product information, and it's the very core factor that affects performance. Because of limited thickness and weight, it's important to make full use of inner space in laptops for its maximum performance release, aka more power, less heat. To make it happen, we need to enhance the cooling capacity to further reduce the heat generated by the laptops. At the same time, increase energy efficiency for high performance at the same wattage. Different goals, different designs. If it aims for long battery life, then priority is the battery. Same as the performance target, priority goes to the cooling capacity. We need to minimize the motherboard area as much as possible, giving space to the thermal modules. Take Yoga Slim 7 Pro 14-inch as an example. We try to compress the space between parts, increase the wiring density of the inner layer, reduce the motherboard area, and increase the size of fans. Also, we optimize the position of large parts on the board to avoid heat pipes as far as possible, to make heat pipes and thermal modules design more reasonable, and eventually improve its heat dissipation capacity. Yoga Slim 7 Pro 14-inch is just 14.6mm at the 6th point, has a nice card on the front to ensure it looks very thin. Sleek and light design it is, but never light on the power. 42 watts TDP, all credits go to our thermal engineers, but how to make the best of it? System tuning is the key. CPU is like engine. As we know, to get more power in a car, single-cylinder engine is not good enough. Double-cylinder engine is better. Two pistons inside the cylinder move up and down in unison. The power output, however, is not even. After this, automotive engineers make two pistons work together. Then came three-cylinder engines and four-cylinder engines. Yoga Slim 7 Pro 14-inch is powered by a three-cylinder engine and three-phase power supply. Each phase works at 120 degrees. The three-phase power supply together forms a full-cycle power supply of 360 degrees, which can complement each other perfectly, ensuring a stable output of 42 watts all the time. And it also has turbo boost feature. Instantaneous turbo gets 64 watts tops. For users, it doesn't have to be running all runtime at 42 watts. Only 3 to 10 watts for daily office use and entertainment is enough. For Yoga Slim 7 Pro 14-inch, switching power frequency is quite similar to the engine speed, and it is adjustable from 20 kHz to 600 kHz. To ensure optimal efficiency, three-phase power supply is not always working together. When it's ranging 42 watts, a three-phase power supply, 50 watts to 5 watts is two-phase power supply. 5 watts below, only single-phase power supply in the work. However, it is not easy to do a multi-phase power switch. For single-phase power supply, not only does it have to complete a full cycle of 360 degrees power supply, also to meet a double-phase power supply of respective work at 180 degrees, and to adapt to the three-phase power supply at 120 degrees. Frequent phase and frequency switching brings many compatibility problems. Exactly when to add frequency, when to phase, this requires careful calculation and a lot of debugging. Only in this way can three-phase power supply deliver more power in a more stable and efficient way. More power, less heat. This perfect balance between high performance and effective heat dissipation, in fact, also contributes to the battery life. Previously, we mainly focused on the CPU workload. Yoga Slim 7 Pro 14-inch also comes with discrete graphics. It is not easy to allocate the right amount of performance power to CPU and discrete graphics. When the graphics card also works, the CPU cannot take up this 42 watts TDP exclusively. It depends on the real use scenario to decide which one gets more power. Again, take the car as an example. On high-grade surfaces, such as paved roads, press curve and torque apply on the front wheel, just like our daily online office, all assigned to CPU and GPU. Switching to real-time all-wheel drive, torque is distributed between front and rear wheels. Like our working scenario, we might need to draw a map and look up information online at this time to automatically match the CPU and discrete graphics power. Off-road hill climbing transfers torque to the rear wheels, same as the gaming scenario when discrete graphics cards gets more power for smooth gameplay. That is all for today's Spec Talk on power distribution and management from the underlying hardware perspective. Later, we'll take a deep dive on software and hardware integration, on performance and power dissipation. More stories to come. Thank you all for watching. See you in the next one.